Question number 7. There is a cantilever truss given to you and force in the member B is asked. Okay, first let me draw the truss. This is joint C, this is given as joint D, this is given as joint B. Apart from this angle is given as theta, this point is E, and this joint is A. So I have used point, joint and pin, the same word for these particular joints. So I hope you all understand, that is, to this we can say point, joint or pin. So here is 60 kilonewton acting at point or joint E or pin E. Now it is given as, this is given as 5 meter, and again this is also given, I hope, okay, 5 meter. Now there is one more force acting at A, that is downward, and its magnitude is 20 kilonewton. Okay, now, and this angle is theta given. What is asked to me is the force in member BE. Okay, force in member BE. I'm not going to use method of section here. I know that method of joint is going to give me very easily result, because to find out force in member BE, either I need to consider on joint B or on joint E, and I hope you understand at joint B all of you can see that 1, 2, 3, 4 members are meeting, and forces in all the 4 members is unknown. So first I need to find out force in the 2 members, then only I can find out the force in the rest of the 2 members. But if I consider at joint E, can't you see easily the members are in horizontal and vertical direction, so it will be very easy for me to find out at joint E, because there is only 2 unknowns at joint E. Okay, you must be thinking that there are 3 members, but the force unknown is just 2 values. So first I'm going to draw joint E. Now it is 60 kilonewton acting at joint E. Now there is one member BE, and there is one member DE, there is another member EE. Okay, now see these particular members, the members can offer force. EA member can offer force in this direction, DE can offer in this direction, BE can offer in the vertical direction. And I hope you all understand that the force offered by member DE or EA will be in the horizontal direction, so that cannot cancel out this 60 kilonewton. To cancel out this 60 kilonewton, there must be some force in the vertical upward direction offered, and that force can be offered by member BE only. And now if I simply see, if this is a truss, so it will be in the equilibrium, so it's each joint and any of the member will be in the equilibrium. And what about the considering equilibrium at a joint, the net force must be equal to 0. So I'm taking force in the vertical direction equal to 0. So it is coming out as FBE 60 kilonewton. 60 kilonewton. And I hope you all can see that this particular force in member BE, see, this member has exerted pulling force on the joint. So by Newton's third law, this pin or joint will exert the pulling force on the member BE. So member BE, this force in member BE will be 60 kilonewton, and its nature will be tensile. What is the meaning of tensile? It will create the tension in the member BE. So our member BE is in tension with an intensity of 60